Hello, my name is Aman Shah. I completed my bachelor's in mechanical engineering from Jadavpur University and my master's in aerospace engineering from Indian Institute of Technology, Kanpur. For the last 4 years, I have been working as data scientist in the field of computer vision, natural language processing, machine learning operations, as well as creating full stack solutions for deploying these ML and deep learning models to various edge devices as well as cloud services. Today, I will present to you Automated Advanced Traffic Monitoring System AATMS. That is the current state of the art intelligent traffic monitoring system. So the current gap is that the most of the experimentation and models people are coming up, they are limited to only Jupyter notebooks, and hardly few of them reach to production level. As well as these, there are custom trained models such as Ultralytics YOLO model, which are basically trained on COCO common object of context dataset and not on the real life dataset in the Indian context. So that is the main bottleneck problem in terms of having custom computer vision models in traffic monitoring system. So that is the one thing. Apart from that, so when we are dealing with a computer vision pipeline deployed at various scale, on city scale, so you might need to have a team of computer vision engineers. You might need to deploy a backend team for APIs and managing the database, separate data analyst as well as a front end team to visualize and get meaningful insight from the traffic node. And you might need to then store all these huge traffic data and then do post processing and may generate some prognostic or maybe some forecasting about the traffic density at various nodes. So all of these comes with latency. So these are the current bottleneck problems that intelligent traffic monitoring system has, which limits the boundaries. But today I will present to you AATMS, Automated Advanced Traffic Monitoring System, which solve this problem. AATMS is trained on 250,000 of a custom annotated data set from Indian scenarios containing 26 different classes of Indian vehicles such as auto rickshaws, e-rickshaws, scooties, bicycles, bikes, pedestrians as well. So you can use various cross-platform services. We provide live inference services from using RTSP streams, IP feed cameras, as well as you can upload your own custom MP4 files. Let me take you to the front end so you can better look at how it works. So you can just log in with your details first. Let me log in first. So we provide live monitor services. This service, you can even provide live RTSP streams. You can even upload custom videos as well. So currently, ATMS has provides two services, that is line crossing and the polygon zone presence. So I will show you a small demo how it works. So I'll just take some random videos and I'll just object in context data set. But apart from that, we also support various models having different sizes, quantized models, smaller models, faster models. You can run it with close to 60 fps size. So let me just take a small model. We will use this 192 mark 0 pytorch. And you can the ADMS currently support three tracker: bot sort, byte track, as well as deep sort. So let's just go with deep sort. And first it will tell you to create the zone. So say let us say I'll create the left park. So you can just create the left park and then just, and you can save metadata as well. Save this information. You can also create some another zone. Okay, here this closes polygon gives some. I'm just providing some random values here. uh, okay, just save this information. Now we have two zones here created, and just you can just proceed to live analytics. We will just start. So as as different vehicles presence, it tracks them, and it gives you all the information in real time, how different events have been going, uh, how many vehicles have been passed from the left park, the region, how many vehicles passed from the right park. It also provides a mini map. You can also visualize it. At the end of processing, it will provide you it will provide a JSON file as well as .csv file of the all the object count, as well as the instant when the object entered and exited the region of interest created by the user. So it provides all this flexibility. Apart from that, this all this information data gets stored here, and in a local Postgres database, as well as the deployed software uses Supabase to store all the information. You can visualize all this here. So you can visualize this interactively here, how this info how the heat maps have been generated, how the road traffic networks have been connected, and you can just play the animations and visually how these various nodes have been interacting. So this uh, we have created from the original data set. We deployed ATMS in a in a in a in a certain region of interest in Delhi area, and collected data set from that. And I'm just using 2 days of data to simulate the how we predict that the traffic networks, and how you can interactively visualize this in real time traffic monitoring. You can store the data, you can visualize all this information in real time system. So the best part of the software apart from this is its flexibility system, such as you can deploy it on Raspberry 5 Pi 5. It is running with Coral TPU support. You can run it with Jetson AJX Orin. It has Nvidia CUDA enabled GPU to run faster inferences. You can even deploy it on your local Windows CPU, as well as it supports deployment on Ubuntu devices as well. If one interested in developing and deploying the system to cloud services, they can connect with me. We can talk about it more. And yes, sure, we I am open for contributions and having more suggestions in this project. And thank you everyone for your time, and thank you.